All right, hello. Thank you all for coming to this talk. I'm Robert Neal. I lead a group within product delivery at LaunchDarkly called Decision Science. We work on decision science products, including experimentation. And today I'll be talking about an underrepresented subject, might be something you haven't heard about before. It's called generative AI. Maybe by a show of hands, has anybody heard of generative AI? Oh, well, color me green and call me a pickle. I guess I'm wrong. I'll talk about generative AI, but I'll specifically be talking about it in the context of experimentation. My background is in decision science, including experimentation. So I'll be talking a lot about some of the problems that we have in experimentation and some cool ways that LLMs specifically help us solve these problems in really novel ways. And I'll be talking about it within a context of a project that we recently launched. So first, I want to tell you a little bit about our company because it helps set the stage for the sorts of problems that we're solving. So LaunchDarkly has over 5,000 customers, and they run the spectrum. Almost every conceivable industry uses LaunchDarkly. And this poses some unique challenges for developing decision science products. So just as way of an example, I've worked on experimentation at a bunch of different companies. Previously, I was at a company called Twitter, RIP. And I've also been at other companies building experimentation products like Credit Karma and Udemy. And those are all internal experimentation tools. So our customers are internal customers. And honestly, that makes building experimentation products a lot easier. When you're building for so many customers, here's just a few examples of the types of customers we're working with. In all different kinds of industries, experimentation becomes a lot more challenging. The types of decisions people are making, the types of metrics they're using, the type of experimental design they need vary very much more widely. And this causes us to run into some issues that really require some domain knowledge. And you'll see how LLMs unlock some potential there. So first, I'll talk about sort of the baseline. So any good experimentation system needs a parameterization system. They sort of go hand in hand. And LaunchDarkly started as a feature flagging company. And the idea was that LaunchDarkly would decouple deploys from releases. So the idea here is, I'm sure many of you in this room have had this experience where when you deploy your code, it's live in production. And if something goes wrong, you have to roll back a deploy. This causes a lot of challenges. If multiple teams have merged something into the main branch, when that deploy goes out, if one team made a mistake, everybody's changes get rolled back, right? So the key insight when LaunchDarkly started was that we wanted to decouple those things. So you could release things, and there's no behavior change in your code, and then each team could release features on their own timelines, and then roll them back individually if something went wrong without rolling back the whole deploy. And this is a really critical component for experimentation. So when you run experiments, you want to be able to remotely control those things without having to, say, release a new version of your product or features. So why experimentation? Experimentation is a pretty interesting space. There's a lot of meta studies on experiments, and they all end up showing the same thing, which is that if you just go with your gut, you're going to be wrong a large percentage of the time. So this study says 90% of the time, you'll see numbers between 70 and 90%. And the problem with that is if the way that you're thinking about product development is that you come up with a good idea and you just think really hard about it, then you're going to come up with the right feature, you're going to ship it, and your company's going to make more money or sell more widgets or get more clicks. But it turns out that that's almost universally wrong. If you don't experiment, then it's hard to measure the effectiveness of your feature, and you often make mistakes. Another big reason people come to us to use experimentation is personalization is really big. So one cool thing about LaunchDarkly is it's also a rules engine. So you can target different users. So for example, let's say that you want to serve a different version of your feature to people in the US versus people in Europe, or you want to target people in a certain age group, or let's say you're even using it for like entitlements. Like let's say you have a pro version of your plan and a starter version of your plan. So you can control all this with LaunchDarkly with our feature management system. And the nice thing about that is you can then experiment on those individual segments. What you end up doing is like building an optimized personalization engine. And I just want to maybe paint this in contrast to ways that some product teams deliver products, and certainly I've been on teams like this, so I'm not saying it's like they're bad teams, it's just like this mentality where you're a feature factory. So you definitely want to stay away from just shipping features and then like patting yourself on the back because you shipped a feature, right? Like you want to know that it's valuable. And so experimentation is really the gold standard for measuring whether or not something's valuable. Just really quickly, I can contrast that with what some people call like pre-post measurement or diff and diff analysis, which is like you ship something and then you measure the effect of it after you ship it, and you compare that to a previous time period, and you look at the difference. The problem there is that if there is a difference, you can't attribute it with very much certainty to that feature. Maybe there's like a marketing campaign that happened at the same time. Maybe another team shipped a feature at the same time. So really you want to use experimentation, and the way experimentation works is it randomizes traffic to both the old thing and the new thing, and then serves those two different groups, or in different groups, different versions of the feature. That way, if there's anything else happening at the same time, it's affecting both groups equally. So you can take that measurement to the bank for the most part. Cool. So I talked a little bit about this already, but I want to just go into a little bit of detail about how different this way of shipping products is, which will help set the foundation for how LLMs are so powerful here. So when I was at Credit Karma 10 years ago, we shipped like this. So we had a big PHP monolith, and everybody merged to the main branch. And then once a week, we'd have this brave soul who would deploy the product. And he would deploy it, and then he'd watch to make sure none of the metrics were affected. CPU, memory, clicks. We had a bunch of key business metrics that we were watching. And if something went wrong, the whole deploy had to be rolled back. But importantly, like it was kind of weird because we knew how painful it was to roll back entire deploys. So we'd have to make these judgments like, is the negative effect of this deploy bad enough to cause us to want to roll back everybody's changes? And it was a really painful process. And this was one of the big reasons why we built out a parameterization and experimentation system at Credit Karma. And the interesting thing there is we still shipped at the same cadence. And by ship, I mean deploy. We still deployed once a week, but people were able to release their features all the time, turn them on, turn them off independently. So that was a big change for us. But one of the important things to notice here is that let's say that you do just introduce this run an experiment step into your process. That's not enough by itself. So like imagine one way you can introduce running an experiment into your deployment and release process. You could just say have some code that has like a conditional, and you say, if this user is randomized into the first 50%, then I'm going to evaluate this code. If the second 50%, I'll evaluate this code. You still run into that problem where if something goes wrong, you have to roll it back. Or if you find out the experiment is successful, you have to do an additional deploy to roll that out to everyone. So you really want a feature management system or a remote parameterization system that allows you to modify those things without doing a deploy. So you want those parameters really to be served from some location that you can modify without an additional deploy. And the way that I like to think about this is parameterizing your code and thinking about it like a model. So like think about like any statistical or machine learning model, you can think about your code base as a model. And the way that we think about experimentation in like a data science perspective is it's about policy optimization, where an optimal policy is like the thing that maximizes value for your business. So you want to find the optimal policy, and you're doing it via software. So like for a lot of us, our products are our software, and so we need to optimize our software to maximize business value. So you can think about your code as a model, and you can parameterize that model. So think about things like, even things like, I don't know, text on buttons or images, or even like continuous parameters, like if you have some sort of thresholds for alerting, or you have any kind of like numbers that you use to maybe determine how many features are shown on a particular page, like think about like a recommendations engine, anything like that, or even like character count in comments. These are all things that you could parameterize and figure out how to find the optimal value for your product. And so like in like a optimization sense, you can explore the entire parameter space for all these parameters, and then you'll have the best possible product, right? I mean, that's the ideal. It doesn't quite work like that in practice, but you do want to take sort of steps toward that. And the way that you can do that optimally is by parameterizing it and letting yourself explore those parameters without having to change your code. Actually, I'll tell one more anecdote there. When I was at Udemy, we would do these, if you've ever used Udemy, you'll probably know this. They had monthly sales. And so you'd have like these courses that cost like $350. But anybody who used Udemy knew that if you just waited a few weeks, there'd be a sale and it'd be like $11.99 or whatever. And so we'd do these 3-day sales all the time. And when I joined Udemy, the way that they experimented on this was an engineer would go in there and have an if statement. If the person's in this variation, show this headline text and this image. And if they're in this other variation, show this other headline text and other image. So every time we had a sale, we had to have an engineer go in and code up those differences. Now, one nice thing was we could remotely control like how much traffic these variations got. So we could turn something off if it went wrong. But we couldn't remotely control the parameter values themselves. So one thing I worked on while I was there was building this parameterization system, which allowed marketing to not have to rely on engineers to do that. They could just, so the way you can think about it is like you have variables in your code. Those variables point to usually some static string or something, but instead it could be pointing to your remote parameterization system. And then someone like marketing could just modify those parameter values, create a bunch of them, and serve them without having to have an engineer involved. So the nice thing about that is when you deploy your software, you no longer have to hope that you included a variation that is going to be the winner. And I'll talk about this in a little bit, but when you think about exploring the parameter space and how much different that is than how people do product development, it's pretty striking. So imagine like you come up with a product idea, and it's a great idea. I mean, we talked about 90% of ideas being bad, but that's people not in this room. I'm sure for all of us, we have really good ideas. So we come up with this really good idea, and then like the way it works is we usually go talk to design and go talk to product, and they're like, oh, well, we should tweak it this way, we should tweak it this way. And you finally all agree on the best possible instantiation of that idea. But then you run an experiment, and what if you find out that it actually didn't do well? What are you supposed to take from that outcome? So one thing you could take is that your idea is bad. But we know that for us in this room, that's not true. So another thing you might think is just the particular instantiation of that idea is bad. And a lot of people don't actually get to explore that much more because the feature failed and they're already moved on to the next thing. And so what you really want to do is you want to take that idea and parameterize a lot of it. Instead of just like working with design and product and throwing out a bunch of ideas, parameterize your feature such that you can experiment on all of those ideas or iterate very quickly on those ideas once you've launched it and learned that that particular instance is bad. So the idea here is that you have some parameter space, and it's very unlikely that you pick out an area in the parameter space that's better than the thing that you already have, your control. Cool, so now I'm gonna talk a little bit about what I've been working on at LaunchDarkly for the past couple of years, and how my previous experience at different companies influenced this. So I mentioned that I worked at other companies building experimentation products where the customers were internal customers. And one thing that all of these places had in common is that there would be a group of data scientists who were experts in experimentation. And when someone wanted to run an experiment, they would go talk to these data scientists. And they'd say, hey, here's an idea for an experiment that I have. And then the data scientists would be like, oh, you know what? You should use these metrics. Or you need this particular type of experiment design. And then they'd run the experiment, and then they'd go to the data scientists and say, hey, here are the results I got. What should I make of this? But when you're building a product for external customers like we are at LaunchDarkly, you can't depend on them having the same sort of resources. So when we built this product, one of the things that we wanted to do was codify a lot of those questions into the experiment designer in the product itself. So one example is, and I'll show you actually on this next screen, when you first start an experiment, in addition to asking for the hypothesis and the name of the experiment, we ask you what type of experiment you're going to run. Because the type of experiment you're going to run actually changes the parameters that go into your experiment design in really important ways. Like if you don't do this, it could invalidate the conclusion of your experiment, or it can make it very difficult to interpret without a data scientist. So another key point here is the hypothesis. So you can imagine, like, if any of you have used A/B testing platforms before, a lot of them don't have this idea of like experiment types. And in fact, this is a problem that we had at Twitter, which was we built this experimentation platform, and everybody in the company was expected to use it. And so what would happen is people would want to run different experiment types. And they'd say, oh, you know what, we want to run this type of experiment. I don't know, let's say it's a multi-arm bandit. And in order to run that type of experiment, we need your experimentation platform to support some features. And so before I joined Twitter, the team would add features every time someone asked. And when I got there, the experimentation platform was a little bit Frankenstein-y. Everybody's feature was supported, but it became so difficult for people to use because they didn't need most of those features. And so one of the things I worked on at Twitter, which is sort of incorporated here as well, is this idea of making sure that we know the intent that people have when they're interacting with the product, so the product's not overwhelming. So one of the things we do is we ask for what type of experiment you're running. We also want to ask for your hypothesis, which is also critical. So a little bit about my background. I started studying psychology as an undergrad, then moved to philosophy and studied philosophy both in undergrad and graduate school. I started in psychology and then ended up doing philosophy of cognitive science. So have a background in psychological sciences as well as cognitive sciences, and studied experimentation a lot, but as a practitioner of experiments in academia. And one of the things that's influenced a lot of my thinking about experimentation is something called the replication crisis. So this has become fairly popular, so some of you may be aware of it, but if you aren't, the replication crisis was particularly bad in psychology, and the problem was that a lot of studies that we thought helped us understand human behavior were not able to be replicated. So people would find a statistically significant result, but then someone else would try to replicate that study, and it turns out that it wasn't replicable. So people started to have all kinds of ridiculous beliefs about human behavior. One, I guess, prime example is, are any of you aware of power poses? Are you familiar with this? It was a TEDx talk. I think it was like the #2 most downloaded TED talk for a while. And the idea was that if you did some cool power pose, that you would have higher testosterone levels, you'd be more successful. And if you did some other type of pose that was like considered negative, then you would be less successful. So it turns out that you couldn't replicate that. And the problem there was that what a lot of people were doing in psychology and nutritional science and all these things, where they would run these experiments, they would track dozens of metrics, and they would just look for the ones that were statistically significant, and then they'd make up some sort of narrative to fit this. And so the reaction to this, to sort of fix this, has been something called pre-registration. And the idea here is that you state what you expect to happen in the experiment before you run the experiment. And if you find some other result that looks interesting, you don't get credit for having found some new scientific discovery. Instead, you need to run another experiment with that hypothesis. And so that's what this is sort of doing, is capturing that hypothesis, and then you'll see in a second also setting what your primary metric is, so that people don't just go fishing for metrics that move. I'll share one more funny anecdote. So when I was in college, I worked for an online marketing firm. And hopefully none of our clients are in the room, because they might be mad, although it's been like 20 years, so hopefully they'll have forgotten by now. But one of the things that I did was I ran experiments. So I worked as a user experience researcher, and we would design these experiences for our clients, and we'd run experiments. And I was right like 90% of the time. And the reason I was right 90% of the time is because Google had this experimentation product at the time. And you could just keep running it until it became statistically significant in your favor, and then you could report it to your clients, and the clients would write these big checks. It was great. In hindsight, it wasn't really great, because I was just abusing statistics and doing the same sort of things that happen in psychology that made those things not replicable. So we want to avoid those things. We want people to make good decisions. We're in the decision science business, and so we want to help them make good decisions, even if they don't have data scientists. And so you can see how this is sort of setting the stage for like where LLMs might be really interesting. So we capture this. We give you some good defaults. We have you select metrics. Notice that we have a primary metric. This is that idea that you really need to state, like, what is the thing that you think will move? Don't just add 100 metrics, and if one of them moves, pat yourself on the back. You really need to specify that you expect a very specific metric to move. If some of the other, you can add a bunch of other metrics, but if those move, you should really run a follow-up experiment. When you're looking at that, that's considered an exploratory analysis, and to confirm it, you want to run a follow-up experiment. So again, we're codifying all of this stuff in the UI. This is the sort of thing that data scientists would walk you through. Okay, so you choose your flag variation. One of the things that's sort of interesting is if you look across experiments, and this is another thing that's going to be really valuable when it comes to LLMs, if you look across experiments that people run, it's often A/B testing, where it's literally just an A and a B. And maybe we should blame the name A/B testing, but what people are doing is what I mentioned earlier, which is they come up with an idea, and they end up iterating on that idea with their designers and their product people, and they tell their engineers, go build this. And they don't talk about parameterization or anything like that. They say, go build this feature that we finally all agreed on. I got sign off. And they test that one variation against the control. Here we showed 3 variations, but you often see people just doing an A/B test. So let me talk a little bit about that parameter space thing and how it affects experimentation. So I talked a bit about exploring the parameter space and finding an optimal policy. Now let's say that we're doing that thing where we talk with our designers and we talk with our product managers, and we come up with one idea. So if you think about this circle with all the points in it being your parameter space, and you're thinking about picking out just that one way of instantiating that idea that you have, then you're in that yellow circle. So maybe the blue circle is your control, and then that yellow circle is where your idea is. And then if you think about all these other things that you could try, you should think about what is the probability that I picked out like the optimal point in all that parameter space. And these parameter spaces are often effectively infinite. So you have effectively infinite options, and you have one instantiation of your idea. What is the probability that you picked out the best one? So it's probably pretty low. So you could use Gen AI to help with this. And one way that you could use Gen AI is you could go to some prompt interface, and you could be like, hey, I've got this product idea. What are some good variations of that product idea that I might want to test? But of course, that's going to be like, it's going to be sort of inconvenient to go back and forth between this prompt and your product development. And you also are probably losing some information. So one thing that we'll talk about today is how integrating it into a product allows you to use more information and get better product ideas. So let's say that you're still using that prompt. That's good. It improves your exploration a little bit. And then you combine that with feature management, so you can, again, reduce the time it takes to experiment on all these things because you're able to parameterize your idea. You're able to incorporate these ideas that generative AI is helping you come up with. But you still have some challenges. And in fact, one of the problems is you might be exploring the parameter space too inefficiently. So here's one way you could explore more of the parameter space. You could just come up with random numbers or random strings, depending on what you're testing. So let's say you want to test some marketing headlines. You could just have some random English text generator, or whatever language you're using, generate all possible headlines. But that's actually pretty inefficient because it's very unlikely that those headlines are going to work for the use case that you need. So you actually want to both explore a lot of the parameter space, but in a very efficient way. So one of the things that we work on is thinking about how can we use the signals that we have within the product already to help you explore that parameter space in a really intelligent way. So here we know like we can learn from, say, previous experiments, from information about the flag, information about your metrics, information about your hypothesis. We can use all of that information to feed into a large language model to make sure that we're focusing just on the area of the parameter space that's most efficient to explore. Cool. So now that's what we're doing. So now we're saying, look, we've got this parameterized experiment. We're using feature management. That's good. We're using generative AI, but we're using it in a way that's integrated with the product to maximize our search. So importantly, like the idea here is that like generative AI is very valuable here, but only if you're using it in the right way. Like if you're using it very inefficiently, then it's moderately better. But like if you really integrate it into your product and you leverage the data that you have, then you're going to get way more value from that generative AI interaction. So I'll tell you a little bit about what we're doing specifically and how we're integrating with the large language model. So when you fill out this experiment, you're putting in a name, you're putting in a hypothesis, but you also have historical experiments that you can draw from. And we can actually feed those into the large language model to figure out like what sort of things have worked before. So instead of just saying, like let's say that you went to Amazon Bedrock and you pulled up the prompt for Titan and you said, hey, I'm running this experiment where I want to optimize for, let's say, a particular audience, and this is the type of experiment I'm running, you're going to get good results. But if you take historical information and information about your product feature that's already in LaunchDarkly, you can get an even better search space for the parameters that you're trying to experiment on. Cool. So I talked a lot about how that's helping. I think there's one other thing I wanted to mention, which was when you think about like the way that we interact with generative AI, especially within LaunchDarkly, we have a lot of information. And one of the things that I mentioned earlier was personalization. So think about personalizing your product. One of the things that you might want to do is you might want to say, change how you display products for certain audiences. I mentioned before, it could be different countries, it could be different age groups, what have you. We're able to take all of that information and put it into the prompts for generative AI to come up with really interesting results. And I'm going to show you a demo, a short demo, in just a second on how that works in the product. So this demo is a demo by Arnold. Arnold's here in the front. So Arnold is the primary engineer who built out this product, and so I want to thank him. I'll show the demo. Also, shout out to Joni Rastulka, who's our lead designer for decision science, who also worked really hard on this. So here we go.
Hey, I'm Arnold. I'm an engineer at LaunchDarkly, and I'm here to walk through a use case of using AI to help build an experiment on an e-commerce website. Let's say I'm building a store called Toggle Outfitters, a shop selling toggles. I've noticed that we've had an uptick in customers aged between 20 and 25, but a downtick in the number of toggles we've been selling, especially to the customers in that age range. So someone on my team suggested that the text we have here on the landing page is not really relevant to our new audience, and that we should try out some different options to see if we can sell more toggles that way. Let's use LaunchDarkly Experimentation to run a test on a few different snippets of text. Here we are in the LaunchDarkly Experiment Builder. To start, I'm going to name my experiment and write out my hypothesis. In other words, the expected outcome for my experiment. So let's name it Optimizing the Tagline Leads to More Conversions. And our hypothesis is going to be improving the text on the landing page will increase the number of product purchases. Once we click Next, LaunchDarkly's AI assistant will read our hypothesis and provide some suggestions on how we can design our experiment. Now we need to select a metric for our experiment. The metric we're looking for is whether a user purchased a toggle. Normally, I'd have to search through the list of metrics and know the exact name of the metric I'm looking for, but we can see here that the assistant has already found the metric I'm looking for, or at least suggested a couple of them, and it looks like purchased product is the right one. However, it also suggested that if I wanted to create a new metric, I could use this name for that metric. Cool, let's continue. Next, we'll need to choose which feature flag will control our experiment. I can see some recommendations here, but none of these look quite right, so let's create a new one using the AI's suggestion for a name. The suggested name for this flag is landing page text, but after seeing the couple of flags that refer to the section we're editing as the header, let's just go ahead and call this flag header text instead. And the description looks pretty good, so let's work with that. Cool. Now we need to come up with some variations of text to try out. Let's make the control variation the text we're already using. We need some new variations to try out. Let's use AI to help us out. Let's tell the AI, I'm optimizing the hero text on my e-commerce site selling toggles. Suggest new variations targeting a Gen Z audience. Once I click generate, the AI will use this prompt and my existing variations to create new ones. Awesome. Some of these look great, but I don't like the second one, so I'm going to remove it. I still want some more variations, so let's ask for more, but also say that we want emojis in each variation. Click generate. Sweet. We've got variations with emojis. This one's a little long, so I'm going to delete it. Let's create the flag. And now that we have our feature flag with all these generated variations, we can go ahead and start an experiment.
Cool. So one of the cool things about integrating the LLM into the product is the interface looks really simple and really easy to use, but we're doing a lot under the hood to make it really valuable. So Arnold in the demo showed that we are that you can prompt it with specifics if you want to, but it's also adding a lot of additional information into that prompt. And all of that is done under the hood, which allows you to have like a really seamless experience and really get a lot of value out of the LLMs without the end user knowing what's going on at all. Yeah, so this is really cool. So it allows you to generate more ideas without adding complexity. You can see that like that was a key thing for us, is that we really wanted to make it so that you could easily generate more variations without making it more cumbersome. You don't have to go to your prompt in some other product for getting ideas. You can do that all under the hood, and it would leverage the existing data that we already have in LaunchDarkly for you. And this is actually a pretty important point. I spend a lot of time thinking about experimentation. I go to a lot of conferences. I hang out with a lot of experimentation people. And one of the things that we've been talking about recently in some of the groups that I'm in is this problem of people not exploring enough of the parameter space. And it's something I've been thinking about for a long time, even before thinking about the generative AI applications for this problem, and something that we've been thinking about how we could help with in our product. And we had come up with some ideas previously, but LLMs really make it super easy to encourage people to explore more of that parameter space in ways that we had struggled to solve for before. And especially in this product area that we're in, where we have external customers who have varying domains that they work in. Like I mentioned, like the industries we work with run the gamut. You saw some of them on a slide earlier, things from Ryanair to GoDaddy, very different companies. And when we're thinking about, think about a pre-generative AI world, how do you encourage those people to come up with more variations for the things that they're experimenting? And again, this is a place where you would typically have a data scientist who has expertise in experimentation consulting with you if you were working on an internal experimentation system. And I want to highlight that a bit more as well, which is, so I told you this journey that we went through where we designed this experiment builder 2 years ago with the idea that it would codify a lot of the things that data scientists would ask when you're designing an experiment. And it would integrate that into the experiment setup so you wouldn't have to have that data scientist that's sitting right next to you. But we always knew that there were these gaps. And one of the cool things is that generative AI has made it very easy to fill those gaps in ways that we couldn't have imagined a year and a half ago. Cool. So I think next I'm going to talk a little bit about how we used Amazon Bedrock specifically, because this has been kind of a cool journey. So we're big AWS users, and we work with Amazon a lot on a bunch of different sort of innovation projects. They recognize us as a very innovative company. And so they came to us, the Gen AI Innovation Center came to us and said, hey, we're wondering if you'd like to partner on a project to use Amazon Bedrock. And we had been throwing around some ideas for generative AI for a while, including this one. And we had actually used some other models to play around with to see how well these ideas might work, and weren't really happy with the results. One of the things is, being in decision science, you really want people to make good decisions. And sometimes LLMs give you some very funny answers. And especially in experimentation, they often have trouble reasoning about certain things, especially in like statistics and probability. So some of the ideas we were a little on the fence about, and we had some bad results. But then Amazon came to us and gave us access to Amazon Bedrock. And so we jumped in, started playing with the Titan model, and within a day we had validated an idea. So it was really great. We used the prompts just in Amazon's UI. We're able to validate the model, figure out that actually gave us some really good results. So the next thing we did is we figured out, we wanted to figure out how easy it would be to incorporate it into our product. And of course, one of the benefits is we're already big on AWS. So it's already got all the security that we want, and especially like thinking about transferring data back and forth. So one of the things that we do is we leverage our customers' data, and it's very important to us that our customers' data remains private and only that customer has access to it. And when we're leveraging that data, one of the things that we're doing is we're actually encoding a lot of that data and throwing it into a vector database so that when customers are building experiments, we can use the LLMs to take advantage of those vectorized, that vectorized data and give really good results that are specific to the customer. And this is, again, like an area where when you have that domain-specific experiment, being able to leverage that data is really valuable. So we started playing around with that, and within just a couple weeks, we had code in production. And then within a couple months, we were able to build out this entire product feature that you saw. So it's been pretty impressive, I'll say. We've been able to go from 0 to something really impressive in just a couple of months. And it's not just that we were able to build out a product so fast, but working with the tooling has actually enabled us to establish a sort of foundation for future generative AI work. So think about, for example, this flow that we walked through. One of the things that we're doing is when you type in your experiment hypothesis, is we're looking at all your flags and figuring out which flag is a good match for this particular experiment. And so in order to do that, of course, we encode all of your flag names, and we're able to use semantic search to look for that. And so an obvious, easy thing for us to do is to build semantic search into other parts of our application. We've already got that vectorized data. We've already got the Amazon Bedrock in our production code base. And so it makes it very easy for us to continue producing more generative AI features with Amazon Bedrock. So yeah, this is the thing that we just launched. And we're actually building out many more features using Amazon Bedrock. I mean, once we found out how easy it was, we have been evangelizing it within LaunchDarkly and have a lot of cool features coming up. I'll be talking about some of those on January 10th. There will be a QR code in a minute if you want to join. This will be like a remote webinar type thing. It'll be live, but I'm going to be talking about a lot of the cool features that we're building on top of Amazon Bedrock to make LaunchDarkly a better product, not just within experimentation, but across LaunchDarkly's offerings. So there is the QR code for that. And I want to talk a little bit about how we're thinking about building generative AI products at LaunchDarkly. And I think there's like 3 important ways to think about it. And one of them is sort of transformational. So the way that you want to start thinking about it, I think, is what would it look like if I was building my product anew and we had generative AI? What would that product look like? Now, of course, you can't rebuild your product overnight a lot of the times, but it's a good way to start thinking about how impactful generative AI is. And I'll say that I'm pretty gung-ho on the whole Gen AI thing, but I was skeptical up until just a few months ago. So I'm not bandwagony or anything. This is actually pretty cool, some of the stuff we're able to do with generative AI. And I really think that rethinking products entirely is a good way to think about how you might leverage LLMs or generative AI generally, actually. The next way that we think about it is every time we build a new feature, we're now thinking, okay, what is the generative AI first way of thinking about building this new feature? I'm building a feature, but now I have this new powerful computing ability. What should I do with it? And then the third thing, of course, is we already have features. How do we enhance them using generative AI? And the great thing about a lot of the tools that are available, like Amazon Bedrock, is you can go in there, you can play with a bunch of different models, you can prototype very quickly. You could even just validate your ideas. Log into Amazon, go to Amazon Bedrock, play with the prompts, see what it looks like, see what it gives you back, and validate whether or not the idea you have is even reasonable or how you might change it given how you see the models responding. One other thing that's really cool about LaunchDarkly, we just published a guide on Monday. So one of the data scientists on my team published a guide on how to use LaunchDarkly if you're building generative AI products. So in addition to using generative AI in our product itself, LaunchDarkly is a great platform for building Gen AI into your products. So thinking about how you use LLMs and how you validate how good they are. If you've ever used anything like LangChain or anything like that, you're often building these pipelines, and you want to figure out whether or not you're fine-tuning them correctly or using the right model. And the best way that people are doing that today is actually to use experimentation. So you can actually parameterize your pipeline using LaunchDarkly and then experiment on it to figure out which parameters in your generative AI pipeline are the ones that are producing the most value. So we're really excited about that aspect as well. Cool. So I think that's it for me. I'm going to open up to questions. thanks for coming. I guess there's a survey maybe in the mobile app. Also come visit our booth. I've been talking a lot about LaunchDarkly, but one of the things that I found, I actually worked the booth for the first time yesterday, and one of the things I found is just seeing a demo is way more impactful than talking about it. I mean, LaunchDarkly is a really powerful tool, so I really recommend you come by our booth in the Expo Center at Venetian to see a demo. It's a really powerful tool. I'm really excited to be working on it. Yeah, and thanks for coming, and if you have any questions, feel free to ask.